recall that if we've got any 2 points, there's always a unique straight line going through those 2 points. And let's suppose that my first point has particular fixed coordinates that I know. So I'll label that as x1, y1. I know in this example it looks like it's the point 2, 1, but the point is, this is a point that I specifically know. Now my other point, I don't really care exactly where that is. That could be any point at all, so long as it's on this line. So because I don't care exactly about its coordinates, we're going to give it just the coordinates x, y, representing the x and y coordinates of any other point on the line. Now we know that when we've got any 2 points on a straight line, the gradient of that straight line, called m, can be written as the difference in the y coordinates, so in this case that's y minus y1, divided by the difference in the x coordinates, x minus x1. So, multiplying through by the denominator of that fraction, I could write this as y minus y1 is equal to m times x minus x1. And this, therefore, is the equation of that straight line. Any point xy on that line will satisfy this equation. So if we know a point on the line, x1, y1, and if we know the gradient of the line, m, this is then the equation of that straight line. Let's look at an example. Suppose we are asked to find the equation of the line through the point 1, 5 and with gradient -3. So using the idea we've just had, we know that the equation of the line will be y minus y1 is equal to m into x minus x1. In this case then, that means we've got the equation y minus 5, being the y coordinate of the point we know, is equal to -3, that's the gradient that we know, into x minus 1, 1 being the x coordinate that we know. That then is the equation of the line. If you've seen anything to do with the equations of straight lines before, you're probably looking at that thinking, well, that doesn't look like the equation of the straight line that I've been introduced to before. We'll address that in a moment. But for now, just realize that this comes directly out of the definition of the gradient of a straight line. Here's another example. Find the equation of the line through the points -2, 1 and 5, 3. Well, we've got 2 points that we know this time, but we haven't got a gradient. So before we can do anything, we're going to have to work out what the gradient of this line is. So using the fact that we know that the gradient can be worked out using y1 minus y2 divided by x1 minus x2, that means in this case that our gradient is 3 subtract 1 divided by 5 subtract -2. 3 subtract 1 is 2, 5 subtract -2 is the same as 5 plus 2, so that's 2/7. Right, now we've got a gradient and we've got a point. In fact, we've got 2 points. Which one should we use? It makes absolutely no difference. So let's go for the first of these, the -2, 1. The equation of the line, therefore, is y subtract the y coordinate of that point is equal to the gradient, we've just worked out to be 2/7, into x subtract the x coordinate of that point. And it would be very lazy of us to leave this looking like that. It's extremely easy to rewrite that as y minus 1 is equal to 2/7 into x plus 2. Again, we have the equation of the straight line. Now, I said I'd address this issue about how the equation of the straight line we're using may not look the same as one that you're familiar with. So let's go back to what we're using. We're using this idea that if you know a point x1, y1 and a gradient m, this is the equation of the straight line through that point with that gradient. Well, let's expand the right-hand side. So that will give us m times x subtract m times x1. Let's add the y1 to both sides. So y is mx plus y1 subtract m x1. And I'm going to rewrite this so that it looks like this. We'll keep the y the same, we'll keep the mx the same, but I'm going to add a number I'll call c. What do I mean by c? Well, in the previous line it was that number y1 minus mx1. But because x1 and y1 are a fixed point, and because m is a fixed gradient, this is just going to give us a constant, so I'll just call that constant c instead. So we now have a new way of looking at the equation of a straight line, which is one which will be a bit more conventional to you. And we already know that m is the gradient of the line. That's what we used in the first place. What is this value c? Well, if we put the value of x, which of course could be any point on the line, if we put in a value of x of 0, then we'll get that y is m times 0 plus c, which of course means that the value of y is c. That means that the line passes through the point with x coordinate 0 and y coordinate c. So therefore, what do we mean by c? We mean where the line intercepts the y-axis, and we'll call that the y-intercept of the line. Let's look at some examples of this. Find the gradients and y-intercepts of these two lines. Well, in part A, that's very easy because the line is already written for us in a sensible way. We can see straight away that the gradient is 2 because it's y equals 2x, and we can see straight away that the y-intercept is -3. That's the point where this line cuts through the y-axis. What about in part B? Is that really the equation of a straight line? That's a different way from both of the ways we've seen so far. Well, we could start with that version of the line. We could start with the equation we're given and see if we can do some normal algebra to turn it into one of the ways we've seen. And the y equals mx plus c way is definitely the easiest way of understanding what the gradient and y-intercept is, and that's what we've been asked for. So let's start off by subtracting 2x from both sides. And now let us add 4 to both sides. And now let us divide both sides by 5. We've rearranged the equation we were given so that now we can see that the gradient, how many x's we've got, is 2 over 5. Oh dear, I've left out a negative sign. I do apologise. That should have been there all the way through. It disappeared between my lines, so the gradient is negative 2 over 5. And the y-intercept, that is 4 over 5. Well, this example shows us something quite interesting. The way that the second equation was given to us wasn't very helpful. We couldn't see the gradient and the y-intercept straight away. We had to do a bit of work to see that. But the form of the equation is really quite attractive. You've got some x's, you've got some y's, you've got a number is equal to 0. And this is the third common way you might be expected to give the equation of a straight line. We've already seen these two ways. You've seen y minus y1 is equal to m into x minus x1. You've seen the classic y is equal to mx plus c. And a third way you might see a line is ax plus by plus c is equal to 0. And it's conventional for those three numbers, a, b and c, to be whole numbers, to be integers, including the possibility of 0 or positive or negative, but to be whole numbers. It's important to point out that the c in this third form is not the same as the c in this form. Don't read off this number here and think that it's the y-intercept. They are just conventionally called a, b and c. Which is the best form to use? The answer is it makes no difference. However, if you're instructed to use one form or the other for your final answer in a question, you must do it that way. If you're not given any indication of how your final answer should be given, I would go for the first one, because as soon as you have written that down, you're finished. No point in spending extra time expanding and simplifying if you don't have to. So a couple of examples just to practice using that new form. Write the equations of these lines in the form ax plus by plus c equals 0, where a, b and c are integers. So the first one's given to us in a conventional y equals mx plus c form, and it's very easy for us to work on that. If we start off with the form we're given, if we add 2x to both sides, 2x plus y is 1. If we subtract 1 from both sides, 2x plus y minus 1 is 0. There we go. That's a slightly more attractive version. Now let's do the same thing with part B. Well, the rearrangement's not much more difficult than before. We can start off with the y is 1/3 x minus 1/5 that we are given. We can subtract 1/3 of an x from both sides. We can add a fifth to both sides. And that's nearly the right form, but our coefficients of x and the number on the end, they're not whole numbers, they're not integers. So let's multiply the whole thing through by 3, for example, because that will get rid of the fraction at the beginning. Don't forget we've got to multiply everything by 3. And we're nearly there, but still not quite, because now we've still got a fraction on the end. So let's multiply everything through by 5. And there we are. That will do for our final form. We could, if we wanted to, multiply through by minus 1 to have 5x subtract 15y subtract 3 is 0. There's really no advantage to doing it either of those two ways. Either of them would be a perfectly good final answer. So that's all the new content for this video, but let's just look at a few more examples which take these ideas a little further. So suppose we have a question which says find the points where this line in the form of ax plus by plus c equals 0 meets the coordinate axes. So if a line meets the coordinate axis where it cuts through the y-axis or cuts through the x-axis, how can we find those points? Well, if a line cuts through the y-axis, that's at the point where x is 0. So we can just see what happens when x is 0. If x is 0, that means that 2 lots of 0 plus 5y minus 4 is 0. In other words, it means that 5y minus 4 is 0. So that means that 5y is 4. Finally, we have that y is 4 over 5. And so one of the points where that line cuts a coordinate axis is 0, 4 over 5. We can do the same thing for where this line cuts the x-axis, because if you're on the x-axis, then y is 0. And if y is 0, we've got 2x plus 5 lots of 0. Subtract 4 is 0. In other words, we have that 2x subtract 4 is 0. That means that 2x is 4, or that x is 2. So the other point where this line cuts the coordinate axes is 2, 0. In this example, we have to find the point of intersection of the two lines y equals x minus 3 and 4x plus y minus 7 equals 0. These things can be easily solved using your knowledge of simultaneous equations. And to solve simultaneous equations, you'll have your own favourite method, which should be adapted for whichever problem you've got. However, in this case, the easiest thing to do is to take the equation of the second line, 4x plus y minus 7 is 0. And because we know the equation of the first line is y equals x minus 3, then everywhere we see a y here, we should just write x minus 3. So this is going to be quite a straightforward thing to solve. We've got 4x plus another x, so we've got 5x's, minus 3 minus 7 is 0. In other words, 5x subtract 10 is 0, which means that 5x is 10, which means that x is 2. Of course, that's not quite the answer to the question. That's only the x-coordinate at the points of intersection. So what we have to do is take this x-coordinate and stick it into either of the original equations to find the y-coordinate. Of course, the easiest one to do is in the first equation, because y is the x-coordinate 2, take away 3, which is negative 1. So the point of intersection, therefore, is 2, negative 1. Final example, a little bit more fully featured. This is quite a common thing where you will be given lots of different bits of information, be expected to slowly work through yourself. So in this question, A is the point of intersection of two lines given to us in two different forms. B is another point which is given to us, and we need to find the equation of the line through A and B in the form ax plus by plus c equals 0, where A, B and C are integers. Now if we were doing this completely from scratch, we would have to start off by finding what the point A is. I've saved myself a little bit of time here because you'll notice that these are the two equations of the straight lines from the previous example. So we know that A is the point 2, negative 1. But if you were doing this from scratch yourself, you'd have to do that work that we've just done previously. Now B is another point that we've been given, so we have to find the equation of the straight line through these 2 points. We're going to need to know a gradient. So, using the idea that you get a gradient by doing y2 minus y1 over x2 minus x1, we can work out this gradient to be negative 5 subtract negative 1 over 4 subtract 2. That is negative 5 plus 1 is negative 4 over 2. The gradient is negative 2. And now we can use either of these 2 points, doesn't matter which one, let's go for A. So using y minus y1 is equal to m into x minus x1, we have that the equation is y subtract negative 1 is equal to negative 2 lots of x minus 2. Now that is a correct straight line equation, but it's not in the form that's what we're expecting. So let's try and tidy this up a bit. First of all, y subtract negative 1 is the same as y plus 1. Let's expand the bracket on this side to get negative 2x plus 4. And now if we both add 2x and subtract 4 from both sides at the same time, we'll have that 2x plus y subtract 3 is 0. That's a final answer for our question.